video is about solving linear equations, and these are going to be a little bit trickier than those in part 1. If necessary, simplify each side of the equation first by combining like terms. So just on the left side of this equation, 1 minus 3x minus 7, I have a pair of like terms. This positive 1 can be combined with this minus 7 because they're like terms. Neither one of them has an x attached to them, so I can actually do that subtraction. On the left side of the equation, then, I can simplify this to negative 6 minus 3x. Because 1 take away 7 is negative 6. Notice I didn't touch the minus 3x yet. I'm going to leave that alone for now. Bring down the equal sign. On the right side of the equation, the like terms that I see are this 4x going to be combined with this positive 2x because they both do have an x with them. 4x plus 2x is 6x, and then I have a minus 3. Now I can simplify this equation by getting x on one side. I like to do the side that has the fewer x's. I'm going to move those. So the left has a negative 3x. I'm going to move those by adding 3x. On the right, I'm going to combine that with the 6x. So I'm going to line it up underneath the 6x. These give us a 0. Bring down what you have left, which is negative 6 on the left. 6x plus 3x is 9x. Bring down the minus 3. I have the x on the right side of the equation, and that's okay. I'm going to get it alone on the right side of the equation. So I'll move this minus 3 to the left by adding it. It's going to give us a 0 over there. Negative 6 plus 3 is negative 3. Bring down the equal sign. All I have left over here is a 9x. And then 9 multiplied by x, I'm going to do the inverse of that, which is divide by 9, showing it with a fraction mark. 9 divided by 9 is 1, so I don't need to show that. X equals negative 3 over 9 can be simplified, and it's okay if you get a fraction as the answer. Fractions are numbers too. The solution to this is 3 over 9, which simplifies to negative 1/3. Sometimes simplifying each side involves using the distributive property or distribution. So just on the left side of this equation, I can simplify by distributing that 3. 3 times 4x is 12x. 3 times negative 7 is negative 21. On the right side, I'm going to simplify by distributing this negative 2. Negative 2 times negative 2x is positive 4x. Negative 2 times a positive 6 is minus 12. And then I bring down this minus 10x. It's not in the parentheses, so it's not going to get affected by the distribution. I still have something I can simplify on the right. So before I even touch the left side of the equation, on the right, I want to combine this 4x with this minus 10x because they are like terms. That gives me a negative 6x, and bring down the minus 12. Now I can get my x's on the same side. So I have a fewer x's on the right. It's negative 6x. I'll move those by adding 6x. Line it up with the like term. These will give us 0. 12x plus 6x is 18x. Bring down the minus 21. Bring down the equal sign. On the right, we just have a minus 12. X is on the left, so I will get it alone on the left, which means I want to move the minus 21 by adding it to both sides. It'll give us 0 on the left. Bring down the 18x. Bring down the equal sign. Negative 12 plus 21 gives us a positive 9. I'm going to divide both sides by this 18 to get x alone on the left. 18 over 18 is 1, so it goes away. X, bring down the equal sign. 9 over 18 simplifies as a fraction again to 1 over 2. One way to address equations with fractions is to eliminate them in the first step. To do this, we want to distribute a common denominator by the entire equation, and then all of the fractions are going to disappear. So when I look at this equation, I see the denominators 5 and 2. So it's asking me to choose a common denominator for 5 and 2. Common denominator for 5 and 2 would be 10, because both 5 and 2 can go into a 10. And I'm going to multiply that 10 that I chose by the entire equation. Notice I put the entire thing in parentheses to show that I'm distributing this 10 by the first term, second term, and the terms on the other side of the equal sign, first and second term over there. I have to multiply all of the terms in the equation by that common denominator to keep the equation balanced. When I do 10 times 3 over 5x. I will show this intermediate step, though I don't always do this when I'm working, so you can see what I'm doing. 10 times 3 is 30 over 5x. Notice I just multiplied it by the numerator. And I'll continue through the rest of the equation. 10 times minus 4 is minus 40 equals 10 times 1 over 2. Notice again, I just multiply it by the numerator. And then 10 times a negative 9 is minus 90. I know I said all the fractions would disappear, so you're probably wondering why there are still fractions here. It's just because I haven't simplified them yet. Normally I do the simplifying in my head in the first step so that the fractions go away. But here I want you to see what's happening. 30 divided by 5 is a whole number 6. So really there are no fractions left on the left side of the equation. And 10 over 2 is also a whole number, that's 5. So there are no fractions left on the right side of the equation either. So if you choose the correct common denominator, you will end up with an equation that has no fractions in it. And then you can solve it like normal. Let's get our x's together on the left side of the equation because I have fewer over here, so I'm going to subtract those 5x. They cancel. 6x minus 5x is a single x. Bring down the minus 40, the equal sign, and the minus 90. And then all I have to do is add 40 to both sides, because x is already by itself. And it equals negative 90 plus 40, which is negative 50. So that is the best way to deal with an equation that has multiple fractions in it. Choose a common denominator, distribute it through the equation, get rid of all your fractions, and then solve the equation like normal. Some linear equations have special solutions, and you'll see as I start to solve these using the methods we've previously learned, you'll see why I call them special. So in this first equation, I see I have some distribution I can do, so I'm going to start by doing that. 3x minus 7 stays on the left. On the right, I'm going to distribute that 3. 3 times x is 3x. 3 times 2 is positive 6. When I attempt to get the x's on the same side here, I end up subtracting 3x from both sides of the equation. That means that 3x minus 3x goes away on the left and it goes away on the right. So if I bring down what I have left, it's just negative 7 equals positive 6. That's a big no-no, right? That's an untrue statement. It's false. When that happens, your x drops out and you end up with an equation that is not true or a false statement. We say that this equation has no solution. In the original equation, there is literally no value for x that you could plug in that would get you the same thing on both sides of the equal sign. Therefore, this equation has no solution. As we attempt to solve the one on the right, I see I have some like terms on the left to combine. A 3x and a minus x gives me 2x, and I bring down the plus 4. On the right, I'm going to distribute this 2. 2 times x is 2x. 2 times positive 2 is plus 4. You can already see something fishy is going on. When I subtract this 2x from both sides, it ends up disappearing from both sides. No x on the left, no x on the right. When I bring down what's left, I get 4 equals 4. That is a true statement. That equation is always true, no matter what value I plug in for x. Because this equation is always true and every single value will work for x, we say that x is all real numbers. Now, we haven't learned what imaginary numbers are yet. So for the sake of what we've learned so far, every number you know of is a real number. So every number you can imagine plugging into that equation will work. So x is all real numbers. So if either of these situations happens, those are the correct words to write. Now, sometimes you'll see this symbol. This symbol means all real numbers. So you can also write that as your solution if you get a true statement like 4 equals 4. And that is all.